In this video, we're going to look at the probability distribution function for a discrete random variable. A random variable describes the outcome of a statistical experiment in words. The values of a random variable can vary with each repetition of an experiment. We usually use the uppercase X or Y to denote the random variable. Lowercase values of X or Y denote the value of that random variable. If capital X is a random variable, then X is written in words and little x is given as a number. For example, let big X be the number of heads you get when you toss the fair coin. The sample space for tossing 3 fair coins is all tails, 1 tail, and 2 heads. And here we're going to do order matters. We have a head, then tail, then head, 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 tail, 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 head, tail, tail, head, and lastly 3 heads. Then X can take on 0, 1, 2, 3, where X is the getting a head. So X is the capital X is the number of heads you get. Little x is the possible outcomes for the heads. Either you get 0 heads, 1, 2, or 3 heads. Notice for that example, X are countable outcomes. A lowercase x are countable outcomes because you can count the possible values of big cap X and they can take on these outcomes. So, a probability distribution function for a discrete random variable has 2 very distinct characteristics. One is that each probability is between 0 and 1 inclusive. So the probability of getting something could be 0, it could be 1. And the sum of the probabilities goes to 1. So I have to sum up all the possible probabilities and I should get 1. Usually we see a PDF, which is a probability distribution function for discrete random variables, expressed in the form of probability distribution table. So let's take a look at what we're looking at. What does that mean? Well, here is a table. From these 3 tables, we have to determine whether or not these are probability distribution tables. Now, I can cancel out number 5 is equal to negative. I know that B, right out of the gate, just by glancing at it, I know this is not a probability distribution table because of the fact we know the sum, well, the probability has to be between 0 and 1. So we know that isn't going to be 1. So then I just have to look at these 2 and see whether or not they sum to 1 or not. So I would just get my calculator out and I would sum these all to 1. Well, this one, A, does not sum to 1. So we know that that is not a table for a probability distribution. And so the only one we have, by checking my calculator and summing up all of these probabilities, and that means these values here, is equal to 1. It's only C. C is the only table that represents a probability distribution. The table below shows a probability distribution for the random variable X, where X represents the number of movies streamed on Netflix each month. So here's my table. What is the probability of streaming at least 3 movies each month? Well, to do this, that means I would have the probability of 3, 4, and 5. So the probability of X, capital X, is greater than or equal to 3. Little number would be 3 here. The little x would be 3 here. This would be simply equal to 0.1 plus 0.03 plus 0.01, which we know then adds up to 0.14. So I have a 14% chance of streaming at least 3 movies that month for this given information on Netflix. So what is the probability of streaming less than 3 movies each month? Well, that would be the probability of less than, so the probability of X less than 3 is going to be 1 minus the probability of X being greater than or equal to 3, which is going to be 1 minus the 0.14, which is equal to 0.086. Now the other way I could have done that is I could have just added up the probability of 0, the probability of 1, and the probability of 3. So I could have done that as 0.06 plus 0.58 plus 0.22, and I'm still going to get 0.86. Either way would have worked. And that's it for this video.